The second part of this, we're going to talk about parallel and perpendicular. Okay, parallel is when I have two lines in a plane that do not intersect, and perpendicular is when you have two lines in a plane that intersect to form a right angle. Okay, so parallel and perpendicular lines are what we're going to focus on today. We also have drawn up slopes of parallel and perpendicular lines. Okay, do you guys remember stuff about slopes of parallel and perpendicular lines? Since it was like 2 years ago. Yes, if they're the same slope, they're parallel. If the slopes are the opposite reciprocal or the negative reciprocal, then it's perpendicular. So I can look at equations and tell by just looking at the slopes in that y equals mx plus b form if the lines are going to be perpendicular or parallel or neither. Okay? Give you guys a second to copy some of that down, and then we will get busy. So you have that red, I guess, under the red, slopes of parallel and perpendicular lines. In your book, they're going to start labeling things like line 1, line 2, that's what those stand for, or they're going to give the lines a specific name, and that way you know how they're referencing them and what's going on. Okay. So then we're given equations in this green area that say, tell whether the lines are parallel, perpendicular, or neither. How would I figure out if lines are parallel, perpendicular, or neither when they just give me sets of points? You find the slope. You find the slope of both lines. So how do I find the slope of line 1? -4 minus 8. Good. So up top, I get -4 minus 8, which is -12. And on bottom, I have ding ding, so I get +4, and my slope comes out to be. Okay. What about line 2? Good. 2 minus 1 over -2 minus -5. So 2 minus 1 gives me 1, and -2 now plus 5, because I had a ding ding, I get 3. What type of slopes do I have when I have -3 and 1/3? Perpendicular, negative reciprocal.
So if it was
So the
negative,
answer is that they're perpendicular.
so if it was negative 1/3, then it would be
If it said what, Cole?
negative 1/3. That'd be
-1/3 would be nothing. Because if these are both negative, it's nothing. Okay, they either have to be exactly the same or opposites. Okay, so it's perpendicular. What about down here on line 1? What do I have to do to see if these are parallel, perpendicular, or neither? -3 minus 2 and 4 minus 1. -3 minus 2 is -5, and 4 minus 1 is 3. So -5/3. What is line 2? What am I going to do? 2 minus 3 over negative 1 minus negative 4. Negative 2, negative 3, negative 5. I have a ding ding. So I get positive 3. What are those? Parallel slopes. Okay, so I have parallel slopes going up. So you're the same. So you're going to have a lot of that on your homework tonight, or you have to solve that one. Okay. There is something called rate of change. Okay, rate of change happens in like day-to-day stuff that we do. Well, that we participate in. Like companies have a rate of change that happens all the time. Employers have a rate of change. Things like that take place. It can be represented through slope. Okay, but often we use slope to figure out what the rate of change is. And it's basically how much one quantity changes on average relative to the change in another quantity. So it's like a comparison or compare and contract things so that you can see what's going on. So when they do rate of change, it also can happen with like how things grow or what's taking place in the world. So basically, the problem they give us to look at is they give us 2 tree stumps, one from 1965, okay, and one from 2005. And they say this diameter is 137 inches. This diameter is 141 inches. Okay. They want to know, use the diagram, okay, which illustrates the growth of a giant tree to find the average rate of change in the diameter of the tree over time. Then predict the tree's diameter in 2065. So how could I use slope to figure out the rate of change? Okay, you want to do 141 minus 147 or 137? So if I take 141 and minus 137 from it, okay? Now in slope, I have to have 2 components. I have to have an x and a y. Technically, we just made this our y. What is our x? The years. Our x can be our years. Okay? So what, I need to take 2005, right? Subtract 1965 from it. What does that come out to be? What is 141 minus 137 over 2005 minus 1965? The one on the bottom is 40. The one on top is 4. Okay, so I have 4 inches and I have 40 years, right? Okay, what is 4 over 40 reduced down to? 1/10. Okay, so I have 1/10 of an inch per year. It grows 1/10 of an inch per year. Does that make sense? Okay. So now they want to know in the year 2065, how do I figure out how big it is in the year 2065? How could I come up with that? We know that right now it is currently 141 inches. And that is in the year 2005. We want to know how large it will get by 2065. Okay, so I'm going to use this ratio that I got somehow. And you're right, I'm going to subtract something, but I'm not subtracting with that. I'm going to take this. Okay, when we think about the equation of a line, what does that look like? Y equals what? Mx plus b. What is my m? What is my slope right now? 1/10. Okay, so technically I'm going to multiply that by whatever is next to it. Okay. Now, the year that we have right now, the year we know, is 2005. That's the farthest we've gotten in this data. So the question is, what is the difference? Here's what you got to figure out. What is the difference between 2005 and 2065? No. What is the difference between 2065 and 2005? 60 years, right? So if I take 60 years and multiply it by my 1/10, right? Multiply it by my 1/10, you get 6 inches. So in 60 years, it's going to grow how much? Which means how large is it going to be in 2065? 141 plus my 6 inches. Does that make sense? So you have to keep going